Now, okay, so again, let's start. So, what we were doing yesterday was what happened. Um, okay, so let's get started. Okay, we were doing the molality. Okay, molality. Okay, so molality was this moles into thousand upon weight of solvent in grams. Okay, so this was the molality. Now, who else is there? Okay. So this is the molality. Okay, this m into n thousand upon weight of solvent in grams. Now, if you look into this and we suppose we want to insert the mole fraction. Okay, mole fraction. What happened is mole fraction. Now, mole fraction I am representing by mf, that is your mole fraction. Okay, and for solute I will be writing mole fraction of solute MSU. For solvent it will be MSV. Okay, so this is your mole fraction. Now, if you so we have to insert this mole fraction formula into the molality formula. Okay, okay. Now, molality is your number of moles of solute into thousand upon weight of solvent. Okay, this one. Now we know that moles of solvent. Okay, and solvent is your moles of solvent. So moles of solvent is equal to weight of solvent divided by the molecular weight. Okay, weight of solvent. Now this weight of solvent we are replacing by number of moles of solvent into molecular weight. So this we can write number of moles of solute into 1000 upon number of moles of solvent into molecular weight of solvent. Okay, that is molecular weight of solvent. This one. So this can also be the formula. Then suppose in a solution there is n moles of solvent, n moles of solvent plus n moles of solute, n moles of solute. So solvent plus solute is your total moles. So n total. Now mole fraction of solute is equal to number of moles of solute divided by n total, and mole fraction of solvent is equal to number of moles of solvent divided by n total. Okay, this. So this is the thing. This you can just write. So here we can write one thing in this. So ms here mole fraction of solute, because I told you earlier mole fraction is your mf, mole fraction of solute is your msu. Okay, sorry, I should write mole fraction. My mistake. Mole fraction. Okay. So mole fraction of solute, mole fraction of solvent, MFB. So here MFU is mole fraction of solute, and this is mole fraction of solvent. So this we can write, and also we can write mole fraction of solute into n total is equal to mole fraction number of moles of solute. Same here, mole fraction of solvent into total moles is equal to mole fraction of solvent. Now this value and this value we can put here. Number of moles of solute is equal to mole fraction of solute into total moles, and here we can write mole fraction of solvent. Okay, this mole fraction of solvent into total moles. So here number of moles of solvent, this value we can put like this. So just we can write this one. Okay, here only we can write. So number of moles MFU into n total into 1000. Okay, this molecular weight will remain. Okay, so molecular weight I am writing capital M into this MFB into n total, MFB into n total. Okay, this one. So this I can write. So here now I can write it here clearly. So molality is your mole fraction of solute into n total into 1000 upon molecular weight of solvent into mole fraction of solvent V into n total. So ultimately what will happen, this n total will get cancelled out. So it will be mole fraction of solute into 1000 upon mole fraction of solvent MFV into molecular weight of solvent. So this is one of the formula. Okay, In between there are so many formulas, but you can remember this one. This. Okay. Sometime in the book, okay, in some books, mole fraction is represented by x. Okay, they just write x, capital X. So capital X of solute. Okay, so they write SOL for solute, or just completely write, or SOLVENT for solvent. So mole fraction of solute and mole fraction of solvent. So you can write like this only if you don't want to write. So this is the formula. Yes. Mole fraction related to molality. So these are the formulas. Okay, but you just remember this. Okay, if you know all this relations, okay, then you can write or you can drive any formula. Okay, and if you don't want to do all this, so just remember this one, so that will be sufficient. Okay, so that will be sufficient. So this is this mole fraction of solute and mole fraction of solvent. Okay, V is for solvent. So here now always I told you mole fraction of solvent plus mole fraction of solute, so it will always be equal to 1. I told you yesterday that when we add the mole fractions it is equal to 1. Okay, so sometimes they can just give you mole fraction of solute, and if they don't give mole fraction of solvent, so there is no problem, you can just insert either of the value, you will get it. Okay, so this is related to this. If they don't give you in the exam, they don't give you the one of the mole fractions, so they can you can write like this. Okay, because solvent plus solute mole fractions, it's always equal to 1. Okay, so this is also related to this. Many a times they have asked related to both of these formulas. Okay, so I hope you got this formula. Got it? So this is, so molality and molarity are exactly same, just you have to write the this weight of the solvent. Okay, so that is your weight of the solvent here. Okay, this one. So basically they are same. Basically they are same. Okay, this one. Okay, have you understood this? Now moving forward, let's take one question. Okay, let's take one question. Density of H2SO4 solution in water is 1.5 gram per ml. Okay, this is the density, and okay. Mm, okay, I didn't told you the percentage. So first let's go for the, this question is not required here. Okay, let's go for the percentage. Okay, so next concept is your one is your remaining is your strength and the percentage in the solutions. Okay, various, so let's start from the new page. Various percentage in solution. Okay, So there is another method to describe the concentration percentage. Okay, so there is various percentages. Okay, if you see any bottle of any medicine or a syrup or something, you will see the percentages there. Okay, on the back side. So there are different type of this percentages. One is your volume by volume. Okay, sorry, volume by volume. Another is your volume. Oh, sorry, weight by volume. Weight by volume. Then there is weight by weight. Okay, and there are a whole lot of subcategories of all this. Okay, subcategories. Now most of the time they are asking about your this weight by weight. This is the most important, but we will see definition. They are very easy. They are very easy. Okay, all these are very easy, just like molarity, molality. But if you know percentage, how to calculate percentage, all things are very easy. Now volume by volume, see, first is your this volume by volume, volume by volume. So here how to see the percentage is this. Suppose we have 90 ml, say, acetic acid. Okay, plus 60 ml ethanol. Okay, so this. Now volume by volume, now in this percentage, so suppose someone asked the percentage of acetic acid. So it is very simple, 90 of acetic acid divided by 60 plus 90. So it will be 90 by 150. Okay, so that is your total, this one, and for the percentage you have to multiply it by 100, so you will get the percentage. So we cancel out. Okay, so you will get 60%. Yeah, 15 6 are 90. Okay, so you get 60%. Okay, acetic acid by volume. So this is simple, don't have to do anything. Okay, just to calculate the percentage there. Okay, this one. Okay, sometime they to find the understanding of the student, they ask the percentage. Suppose they ask percentage of solute by solvent, not by solvent, but with respect to solvent, with respect to solvent. Okay, in above solution, suppose they give you this one. So again the concept of percent will come. Now they are asking solute. So solute, whichever is less is the solute. So ethanol is less, that I told you yesterday. So ethanol is less and this 90 ml is more. So it is solvent. Acetic acid is solvent here, and this ethanol is this solute. So ethanol here, it is solute. Okay, sorry. Ethanol is solute because it is less. Okay, so here, so just you have to do one thing. With respect to solvent they are asking, so ethanol is how much? 60, solvent is 90, and you just multiply it. You don't have to add to volume because they are just asking with respect to solvent. You have to just see the question. Okay, so this is it. Okay, just okay, so you can 15 6 are 90, so 9 into 15 is 60, so that will be your okay this. So it will be 2 by 3, or you can just write 600 by 9, or you can write okay. Okay, just leave it. Okay, so you can calculate it. Okay, 15 6 are 90, 9 9 2, no. Okay, so I was thinking something else. Okay, so that is by volume by volume. Now, so this never comes. Okay, that is very easy concept. So they don't ask volume by volume. Huh? Okay, this one. Okay, okay, okay. So most of the time they don't ask this one because that is a very easy concept. Okay, okay. So okay, so this is your volume by volume. Okay. Now next concept is your weight by volume. Next concept is your weight by volume. Weight by volume. So weight by volume means, okay, suppose there is let's suppose 6 gram glucose is dissolved in 500 ml water. Okay, so suppose this is the condition. So you have to find the weight by volume percentage because we are talking about the percentage. So what is percentage basically? So it is with respect to volume. So whatever is the weight which is dissolved in this glucose, oh sorry, this glucose dissolved in water. So whatever is the weight is there of this solid glucose in some ml of water. So you have to find what should be dissolved in 100 ml. Okay, so what I'm trying to say that suppose 6 gram is dissolved in 500 ml. To find the percentage I should know how much gram is dissolved in 100 ml. Okay, so this is the percentage. So whatever you know, so that is your 6 into 100 about 500. Okay, so that is basically the percentage. Okay, so this is it. That is your 6 by 5. So this is your percentage about weight by volume percent. Or a prince. Okay, so where were we? Yes, so this is your weight by volume percentage. Okay, so that is basically a percentage sort of thing, but it comes regularly in the exam. Now last is your ah what 6 by 5%. Yeah, 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 percent. It is percent. Sorry for that. So it is 6 by 5%. That is 1.2 means whatever you want to, right? Now, yes. Now the most important concept is your weight by volume. Weight by weight, sorry. Weight by weight, and it comes like 99% chances that this question will come. And if they are giving you percentage question, this will come 99% chance. Okay, so wait. So wait 1 minute. Hello. हाँ अभी सो गई हो. So weight by weight. Now weight by weight is same as that of volume by volume. Okay, that is same. Now suppose I say that okay, let's take 5 gram say urea is dissolved in okay, 100 ml water. 100 ml water. So now in case of water, because the density is 1 gram, oh sorry, 1 gram per ml. So density when it is 1 gram per ml, so I can directly take 100 ml as 100 gram. Okay, understand this one. So 100 ml, because density of water is 1, so I am taking 100 ml as 100 gram. So 5 gram plus 100 gram water. This 105 gram urea. So here it is urea, 100 gram water. So total weight is 105 gram. Okay. So in percentage weight by weight, you have to take the total weight, unless and until it is mentioned that you have to take it with respect to solvent, but they don't mention it. So in if it is weight by weight percentage, you have to take the total weight of solution. That is your 5 gram urea, that is your solute, and this is your solvent, and that is your weight of solution. So always remember, you have to take the weight of solution during calculations. Okay. So 105 gram. Now suppose they want to find percentage of urea. A percentage of urea is 5 by 105 into 100. So that is your percentage of urea. Okay, don't do like 5 gram and divided by 100. So that will not be sufficient. Okay, so that will be 0.074 into 100. So it will be 4.7 percentage weight by weight. Have you understood this one? So you have to take the total weight of solution, not the weight of this, because the density is 1, so there is no problem here. You can directly take. Okay, you can directly take it. Got it? All of you are getting it? Okay. Then, okay, sometime I want to point out here there is some confusion there. If they give you a solution, suppose there is small thing that I want to point out, that suppose they give you NaCl in water. Okay, there is a solution suppose, and they give you density of solution is suppose say 1.2 gram per ml. Okay, if they write like this. Okay, now here they have given the density of solution. Okay, density of pure water is always 1 gram per ml, but this is density of solution. Okay, this one. So sometime what student understand this as 1.2 gram NaCl is in 1 ml water. Okay, sometimes student write like this, but this is wrong. Okay, because the weight here, it is the weight of solution, you have to understand, because 1.2 gram per ml, so that is the density. Density is your weight per unit volume. Now this weight, because they are giving you the solution density, so this weight consisted of weight of solute plus solvent. So here in this weight of water is also included. Weight of water is also included in 1.2 gram per ml. Okay, so you can't just take only weight of NaCl here, so that is a wrong thing. Okay, so that sometime because if you don't know the actual concept, so sometime okay, by mistake you can write like this. So that is the thing I want to counter. So that is a wrong thing. Okay, don't do this one. This is not the thing. Okay, understood this one? So this is your weight by weight. So there are several other things that you can do with this one. Now, okay, so, okay, no problem, no problem. Oh, sorry, sorry. Okay, weight by weight. This one. Where is this one? Okay. So now let's take. Okay. Now next concept is your correlation. Okay, I will teach you strength and all that thing. But let's take correlated problems. Okay, correlated problems. Now in correlated problem, they will give you different this molarity or percentage weight and density and all that, and they ask you to find something something. But suppose I give you simple example, simple question that we just did. Okay, so this is your, okay, so I'm giving you on basis of this percentage weight by weight, okay, or percentage weight by volume. Then I will ask you some questions there. Now suppose percentage weight by volume of say NaCl in water is 5%. Okay. What is molarity of solution? Okay. This is, so suppose this is a question. Okay. Now in this you have given this percentage weight by volume of NaCl and water is 5%. So what does this mean? Okay, what is the meaning of this? Meaning of this is, its meaning is, okay, let's do this. 5 gram NaCl is in 100 ml water. Understood this? Okay, because that is weight by volume. So 5 gram NaCl is 100 ml water. Got it? So this is the first thing we have to understand. Then molarity. So just use the formula weight upon this molecular weight into 1000 upon volume in ml. So weight is your 5 divided by 58.5 into 1000 upon 100. So this is your, okay, so this you can do. Okay, so 5 upon 58.5, so you can all this 50 by 585. Okay, so you can do that one. So that is your 0.085. Okay, so this is the solution. Okay, so got it. So this is how you have to find. If suppose they give you molarity, and they can also ask you to find the percentage weight by volume. So reverse question also they can give. Okay. Suppose I am giving you a reverse question. So have you understood this one? This concept? What is this statement you have to understand, then you have to solve it. Okay. So let's take another question. Molarity of glucose solution is 0.1 molar. Okay. What is percentage weight by volume? Yes, anybody can give the answer. Point zero 0.01, 1.8. Yeah, 1.8 is correct. Okay, so molarity is your 0.1 molar here. So 0.1 molar is there. So 0.1 molar means, what does this mean? It means 0.1 moles, okay, are dissolved in 1000 ml water. And 0.1 ml of what? These are glucose moles. Okay, got it. So 0.1 mole glucose is dissolved in 1000 ml. So 0.1 is dissolved in 1000 ml. How much is dissolved in 100 ml? So that will be 0.01. Okay, moles. So 1 mole is your 180 gram. So that is your molecular weight of glucose. We have done it so many times. So what is there in 0.01 moles? Okay, so that will be 1.8 gram. Okay, so 1.8 gram. You can also write 1.8 gram in 100 ml, and so this is your also percentage. So this is a percentage, 1.8%. So 1.8% is the answer. So answer will be 1.8%. Final answer. Any doubt? Okay. So let's take another question. Density of H2SO4 solution is 2 gram per ml in water. Percentage weight by weight. Okay, percentage weight by weight is 20% of H2SO4 with respect to solution. what is, say, molarity and molality. Okay, now anybody getting anything? Okay, so I am just solving it. Now see here. First, you have to see density 2 gram per ml, and this percentage weight. Okay, weight by weight is given. So you have to find molarity and molality. Now okay, for molarity volume should be how much? Volume should be 1000 ml. Okay, so I am taking this density because the density is given in gram per ml. So I am taking 1000 ml here. Okay, so density is how much? 2 gram per ml. It means in 2 gram 1 ml is the volume. Okay, in 1 ml 2 gram solution is there. So in 1000 gram, what is the solution? Solution weight will be 2000 gram, isn't it? Are you getting the first step, all of you? Oh, sorry, 1000. I should write 1000 ml. Okay, 1000 ml. Is red color or what? Which color it is? So that is a 1000 ml. Are you getting this one? Array says yes, no, whatever you want to say. Okay. So this 1000 ml is your 2000 gram. In 1000 ml is 2000 gram. Now what is this 2000 gram? What is this 2000 gram? Teeth? अरे ना भाई. What I told you. See, here I told you. No, no, no. Suppose I told you just here, na. See this. Density of solution NaCl and water. This is a solution. So its density is 1 2 gram per ml. So it is wrong to say that it is 1.2 gram NaCl. That is correct. So 2000 gram is what? Aparajita? Very good, very good. So all of you are getting this. So 2000 gram. Why this color changes every time? I don't know. What is this color? This color is this. Okay, so 2000 gram. This color is again different. I'm confused in the color. What, I'm color blind or what? Sorry, that is a red color. So 2000 gram is weight of solution. Everybody getting this? Prince, Prince, do you listen the lecture or where are you? Okay, Prince is not here. So 2000 gram is the weight of solution. Everybody getting this? Okay. Now in the question, percentage weight by weight is 20% of H2SO4 with respect to solution. It means out of total weight of solution, 20% weight is of H2SO4, 80% is the weight of water. Are you getting this one? Because it is here written weight by weight with respect to solution. 20% is your H2SO4. So out of this 2000 gram, 20% is H2SO4, 80% is what? Water. So out of this 2000 gram, 20% weight is your of H2SO4 plus 80% is your water. Okay. Yes. Please ask. Okay. Okay. So here in 2000, so that molarity you got. Now 20% is the weight of H2SO4, 80% is the weight of water. Everybody getting this one? So what is the weight of H2SO4 out of 20%? Oh, sorry, 20% of 2000. So that will be okay 400 grams of H2SO4. This is 400 grams of H2SO4. So moles of H2SO4, 4.08. Okay. So this is your moles of H2SO4. Got it. Now how much volume we took? We took 1000 ml because molarity is always in 1000 ml. So 1000 ml, 2000 gram, and that in 2000 gram is consisted of 400 gram of H2SO4 and 1600 gram of water. So this 2000 gram is in 1000 ml, and this 2000 gram is consisted of 400 gram of H2SO4 plus 1600 of water. Okay, 400 gram H2SO4 means 4.08 moles approximately your 4. So I can write like this: in 1000 ml, 4.08 moles of H2SO4 are there. So molarity obviously it is 4.08 molar. Okay, there are formulas also, but you should know all the interrelated concepts. What are the correlation between them? Okay, because they can ask you anything. Okay, out of this they can ask you, suppose they can ask you the weight of water in this. Okay, whatever they can ask. So that's why I'm showing you each and every correlation between them. So okay, got this one. So if you have any doubt in the molarity, then you can ask. Okay, so that is your molarity. Now what is molality? Molality is your number of moles of solute into 1000 upon weight of solvent in grams. So for the molality, number of moles of solute will remain same, 4.08 into 1000. What is the weight of solvent? That is your 1600. Okay, 1600 grams. Okay, that is your 1600 grams. So it will be 40.8 divided by 16. So 16 to the 32. So that will be 8. So 16 5 the 19. So 16 4. Okay, 2.4. Is it 2.4 or something else? Okay, 2.55. So let's take 2.55. Jeet, are you getting this? If you have any doubt, please ask. Aparajita? Yes, yes. Yes. Yes, yes, yes. Volume of solution. Weight of solvent. Yes. Any doubt in that? Okay. So I hope. So this question you can revise after say 24 hours. Okay. Normally I upload each and every lecture on YouTube so that you can see it. If I don't give a sometime I forgot to give a link on WhatsApp group, but you can go on YouTube and from the videos you can just see whether it is there. Okay. Now what I was thinking. Yes. So our last concept is your this normality. Normality is there. Normality. Okay. So normality is what? Normality is molarity. Okay, this I am giving you the definition which will work in numericals into F. Okay, this F I told you in the previous lecture when we were talking about acid and base, they are mixed. So that is this F. Okay, now this F is there are various concepts based on this F. Okay, reduction, oxidation, and all that. But reduction, oxidation, I will not teach you here. Okay, that also has this F concept there. Reduction, oxidation, I will teach you after this inorganic concept is there. So then I will teach you the reduction, oxidation. So we will just talk about the this acid and base here. Acid base, yes, that is only the requirement. Okay, so because but this F is all over in the chemistry. Now this F I told you for HCl the F is equal to 1. Okay, for H2SO4 F is equal to 2. Okay, how many protons they are donating? Okay, HNO3 again F is equal to 1. Okay, for H3PO4 that you learned okay yesterday also. F is equal to 3, sorry, F is equal to 3. So that is your F, how many protons. So we are just talking about acid base, no more concept because that will confuse you. You have not studied that much, so that will be very confusing for you. For base I told you yesterday NaOH F is equal to 1, calcium hydroxide F is equal to okay. So just find molarity and then multiply F here. Okay, one, this is one of the definition that will work while doing the numericals. Now what is the actual that what we learned previously, na? HCl donates one. Same thing. Nothing new, nothing new. Okay, so for NaOH there is one OH ion which is donated, so F is equal to 1. For calcium hydroxide, 2 OH ion is donated, so OH F is equal to 2. That's the same thing that we done, okay, in the molarity. We are done with it. Okay, so what we did in the previous numericals, that is same here also. Now what I was again the normality has various definition. One definition which is there, number of gram equivalents, okay, gram equivalents. So gram equivalents is written as GE, okay, we don't write this much, in 1000 ml solution. So that is another definition. Now equivalents, you know, okay, equivalents, you know, okay. So that is your normality definition. Okay, now let's understand all this. What does this mean? Okay. Now equivalent weight, okay, is what? Equivalent weight is your molecular weight divided by the F factor, for, if we just divided by the F. Okay, we did what we did for the valency, because that is for oxides and carbonates, and so there is valency, but that is same as that of F. Okay, suppose for H2SO4 equivalent weight is your 98. 98 is the molecular weight of H2SO4 divided by 2, so it is 49. So F is 2 for H2SO4. Okay, F is 2 for H2SO4, so that is the equivalent weight with respect to acid and base. Okay, now when we write gram equivalents, so gram equivalents or GE is your weight given, that what is weight given in the question divided by the equivalent weight, that is called as gram equivalent. Okay, now understand, this is a very beautiful concept here. Weight, because we are talking about the gram equivalent, so weight upon equivalent weight is what? Molecular weight divided by the F factor. What is the F is there for acid and base, you have to write here. Now this F will go up, so that is your F into weight upon molecular weight, so this one. Now weight upon molecular weight is what? Tell me, what is weight upon molecular weight? That is your number of moles. Yes, moles. So moles we write N. Okay, just we write N. So F into N. So that is your gram equivalent. F into N is your gram equivalent. So that is the definition. So now, okay, sorry. Now here the definition of normality is number of gram equivalents in 1000 ml of solution. 1000 ml of solution. Okay. So this is your gram equivalent. F into. Okay. Now what is molarity? Molarity is number of moles into 1000 upon volume in ml. Okay, this one. Now for normality, it is molarity into F. So when we multiply NF, so NF, because here it is molarity is N into 1000 upon volume in ml. So molarity into F, so NF into 1000 upon volume in ml. So this part is your molarity n into 1000 upon volume in ml, and F is your F factor, that is your gram equivalent. So this, so that is why we write this one. Okay, gram equivalent. So that is now we don't use normality much because that is, we know equivalent weight and all this. So normality is used only 5 to 10% sometime in the this one. But because the normality is also dependent on volume, so it also changes with the temperature. So either we are using molarity or normality. So if you know the F factor, so it doesn't make a difference. People can figure out. Okay, here. So this normality most of the time used in titration. Titration. Have you done titration in 10th class? Anybody? Okay, remove. So it was this normality thing is used in titration. Okay, when you do the practicals, it is there for the titrations normally. But nowadays this molarity thing is also used. So okay, this one. So only definition which is required. Numericals are more or less same. Okay, you have to understand F. If you understand the F factor, then you can figure out what is normality, molarity, whatever. Okay, so there is no this complex topic after the normality. Okay, sometimes they ask you the normality if they give the molarity and all that, but that I will not give because you can understand the concept here, what is meant by the this gram equivalent and all these things. Okay. So this is about the this uh, normality. Okay, this one. So tomorrow we will do, because it is 17:10 now. Okay, this, okay, whatever what is remaining is, okay, law of chemical combination. So that this part is remaining. Okay, so no numerical, I think you will have if the numerical will come, you can do that one also. Okay, don't do numerical on reduction oxidation. Okay, absolutely no numerical on reduction oxidation you should do, because that part you will not understand if I teach you here. That part requires electronegativity and filling of electrons that you don't know. So after teaching you atomic structure and periodic table, I will teach you reduction oxidation. So here don't do, if they are given in the books, but avoid them. They are not required in the first chapter. So reduction oxidation, because the normality most of the time they comes in reduction oxidation numerical. So I don't suggest to do reduction oxidation numeric this normality calculations there. Okay, just do simple acid base if it is given. Otherwise you can avoid. Okay. Yes. 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 This one. Okay, now let's start this law of chemical combinations. Yes. I will. Yes, yes. That is very simple topic. Only 10 minutes are required. L- Law of chemical combination. Now it is not used. It is 18th century, means that is 200 year back thought. Because it is given in NCRT. Normally in pure IT class I don't teach this law of chemical combination, because now it is not required. You have learned a lot about this chemical equations. So okay, or nobody will laugh when I will teach it, because it is a very boring sort of, not boring but it's laughable. Now what is first law? It's your law of constant composition. Law of constant composition. Okay, now in the books there is a definition, but I will just make you understand what it is. So here in this, just understand this one, that elements combine. Combine means chemically react with each other in a fixed proportion. Okay, sorry, in a fixed proportion. Okay, now because it is a 18th century topic, it is now very well understood. Suppose for water, okay, 2 mole hydrogen, means hydrogen atom, okay, plus 1 mole oxygen, always combine. Okay, there is, because they are fixed. Okay, in water it's always 2 hydrogen and 1 oxygen. That is called as law of constant composition. So composition of water will always remain as H2. Everybody getting it? Any doubt in this? Okay, so that is easy. Second is okay, how much time? Okay. Law of multiple proportion. Multiple proportion. Multiple proportion came after the discovery of this carbon and carbon monoxide, sulfur dioxide, sulfur trioxide. So multiple proportion says that if one element combine with another, okay, in different proportion, sorry, in different proportion, they have ratio in simple whole number. Okay, but there are various definitions. Some definitions doesn't match this one, but don't go in the definition. Just understand this one. Suppose it is carbon monoxide and it is carbon dioxide. So in carbon monoxide, carbon and oxygen are 1:1, and in carbon dioxide, carbon and oxygen are 1:2. carbon oxygen. Okay, so what it says that ratio of oxygen in carbon monoxide and in carbon dioxide is 1 is to 2, and that is a simple whole number ratio. So oxygen in this carbon monoxide and in carbon dioxide this oxygen, so that is in 1 is to 2, that is a simple whole number. So that is your multiple proportion. Okay, this is your multiple proportion. Okay, so this is your multiple proportion. Okay, so there are Avogadro, Gay-Lussac. Uh, okay, so there are some concepts which are remaining. Average atomic mass is there, vapor density. So I will teach you tomorrow. Okay, so here we are closing in. Okay, now you can leave, but we have almost completed the topic. Chapter 1 mole concept is completed. Okay, tomorrow I will do all this finishing up. Okay, so please do the question. Okay, you can leave the meeting now. Yes, yes, normality. Yes. This one. Let me comparison. Okay, those who want to leave, they can leave. If you have any doubt, you can ask. Any doubt? Okay. Prince, why are you here? Yeah? Prince?